Hi, my name is Tom and you are at level 32 in Mastering Einstein's Special Relativity. This is the B level, a very interesting topic, faster than light. At the A level I explained that this is different than all other videos on faster than light, and in the A level I told you why that is and what I didn't do. So now I assume you've seen that level, and we are going to see in the space-time diagram how videotaping fast-moving objects totally gets you confused. So the summary of it all was like this. When we tape fast-moving objects, when they come at us, they appear to be larger, faster and further away than they actually are. So you can't believe the videotape, you can't believe your own eyes. And when they are moving away from you, they appear to be smaller, slower and closer than they actually are. So you get a lot of confusion if you wouldn't know about that and trusted the results on your video. And why is this so? Well, this is of course because when we record an object, we actually sense the light coming in the camera lens of the videotaping or your mobile phone, your recording device. And that light took time to get from the object back to your camera, and during that time the object itself kept moving. It didn't wait for it, and that's why we get all these strange effects that are here on the summary slide. Let's see the movie. I cheated a little bit. I explained in level A, so I'm not going to repeat, but for the professionals I discarded Penrose, Terrell, Lampa, etc. It doesn't really change a lot, and I want to stick to stuff happening in the direction of motion. So here is our rocket. We are videotaping it. It's coming towards us and it's stretched, right? Because it is much longer than it really is, and it is actually moving much faster than it actually is. And that all changes when it passes the red line, which is the line where we are. Here it comes, 1, 2, now. And you see that all the stuff of the rocket that passed the red line starts to move slower instead of faster than it actually is. And in the end, we will end up with a very small rocket, which is smaller than the actual thing. So this video is deceiving in many, many ways. Let's see how that looks like in the space-time diagram. For this to work, you need to have seen my episode on the space-time diagram, and especially level 28, I would say, where we apply that knowledge to real-world length contraction. So I'm assuming that you are familiar with those episodes, because we are going to reuse lots of that stuff. So here it is. You can go to this website. I built it, and you can play with it yourself, and you can actually change it yourself. You can do whatever you want. It's out there for you. Let me switch to that website now so I can take you through the story. Here it is. This is the website, and I'm building it up. What do we see here? We see a space-time diagram. The horizontal axis, there is location, or location divided by c if we scale it. And on the vertical is time, or time multiplied by c if we scale it. And I told you in the space-time episode, it's either x over c versus t or x versus ct. In both cases, the diagram will look the same. And in this case, we have a rocket. This is a blue rocket. Here it is. And it's moving at 80% of the speed of light. This is the front, this is the back. And you can just take your mouse cursor and move it up, down the timeline, and see what it does. So here it is. It's just moving at t is 0. It's right in front of me. The middle of the rocket is right in front of my camera, and then it starts to move away from me, and before 0 seconds, minus 40 seconds, it's moving towards me. So it's coming at me, hello, and it's leaving me again. So this is nothing new, right? This is just a rocket moving in space-time, and its width is the contracted length. This rocket, in this example, has a rest length of 25 meters. And if that's flying with a speed of 80% of the speed of light, length contraction brings down the 25 all the way back to 15 meters. So this is actually 15 meters. So this is the truth, but it's not what we are going to see. What I also did is I added a speed slider so you can make the rocket go not moving at all. Then you will see it's exactly 25 meters and minus 12.5 plus 12.5, so it's 25 meters long, and it just moves through time. Its location never changes. It's just where I am with my camera. And I also can make it move very, very fast. And as you see, the faster it moves, the more the length contraction shrinks its length to almost the speed of light. It's just, the whole rocket is just a single dot, and it's moving almost at the speed of light. And speed of light in space-time diagrams are at a 45-degree angle, and this is what you see here. I kept it, I maximized not to go at 1c, because then my formulas break down. Then we start to divide by 0 and stuff like that. So I put a limiter on this slider, but you can change that all for yourselves. But let's now go back to the 0.8. So here we have this rocket, 0.8. Let's put time back when we started filming this. And now I'm going to put the lines in that will show you what you will see on the video. So I'm going to enable the rocket on video. Boom, there it is. Keep breathing. Many lines I'm going to explain to you one by one. If you remember from level 28, at t is minus 40 seconds, the camera receives lights coming in at the speed of light. And where were those photons, that light, coming from at minus 40 seconds? Well, you drop a 45-degree line, which is the orange line here, and you see when it hits an object. And it hits here the front of the rocket around here. So at minus 40, t is minus 40, we see on the video the front of the rocket to be here. And if we follow this line and we intersect it with the back of the rocket, here it intersects the back of the rocket, we will see the back of the rocket here. So if I move on up, those two vertical lines, here in the purple is what we see on video. Can you imagine? This is where the real rocket is. It's close to you. It's almost, because this is location, so it's close to you. And it has the contracted length of 15 meters. And here we see a huge, big rocket at a far distance. I think I ran the numbers. It says, 25 meters at rest, 50 meters contracted. But the video will tell me it's 75 meters long instead of the 15, which is the truth. Now we can play again with the time slider, and I can bring the time up, and you see the purple rocket, the video rocket, moving up. If you notice the slope of the dotted purple lines, you will see that its speed can be measured from this slope. And in space-time diagram, an object not moving is vertical, an object moving at the speed of light is at 45 degrees, and stuff moving faster than the speed of light goes with a slope even after the 45 point. And this is what we see. We see here that this rocket is moving at an incredibly high speed. And if you do the numbers, it's 4 times the speed of light. So you have a video telling you there is a 75 meter long rocket coming at us at 4 times the speed of light. While the truth is a 15 meter rocket is coming at you at 80% of the speed of light. That is how deceiving the camera is. Now let's see how this looks when it leaves us. Let's go here. So I'm going to zoom in. I'm going to take away these labels front and back. I'm sure you can you now by now know what these are. So yeah, this looks a little bit more clean up. So here again, this is what you see on video, because now when it's 40 seconds, we have to drop the photo line and intersect it with the back of the train, which gives us this point. And I'm intersecting it with the front line of the train, which gives me this point. So I see the purple on video, a very small rocket close by, while in fact the real rocket is still 50 meters long, the contracted length, a little bit further away than this one. But also look at the slopes of the lines. This slope is slower than 0.8. In fact, I did the numbers, I think. I don't know what it is. 0.44. Where are you? Oh yeah. Yeah, it's 0.444444. That is the speed of the rocket when it's moving away, and its length is now 8.3, while the contracted length is 15. So this is how deceiving it is. Well, interesting of course is the transition area, because the front of the rocket will be at us and then leaving us, while the back of the rocket will be at us a little bit later. In this case, almost 20 seconds later, we will see the back of the rocket. Well, I think it's, if this is meters, then this is 20 seconds divided by the speed of light. So 20 something, like a fraction of time. But there is delta time here, and then the back of the train rocket starts to do the same. So in the transition area, you see this strange thing going on, which we saw in the animation as well, where you see that the rocket goes like, and then it stays fixed. All right, this is the transition. So there you go. Now you fully understand why all these deceptions take place on video, and it's because of this orange line. You have to every time go from the camera and trace back how the light got to the camera from which object at what position at that time. And that's different than the actual position. And that's it. Yeah. So let's go back to the slides. I think I have to go in here. Yeah. So this is the cube again. And then we do this. Yeah. So this is the end. If you want to know more, there's lots more. I made many levels. Here they are. Well, part of it. I have a second slide with many more. You can pause the video. If you're interested in the headlines, follow the green. Otherwise, you are free to look at the support levels and the optional levels as well. We are now at 25. No, not 25. We are at 32B, faster than light using the space-time diagram. In the next episode, we will derive the equations for the speed, the change of speed versus the actual speed. I want to thank you for watching, and I hope to see you there.